We're really excited to have you here. Thank you. Thank you very much for joining us. We're going to take a deep dive into the Seqera platform and one of the capabilities of Seqera platform, specifically Data Explorer, and Aisha is going to kind of lead the show on that front. Before we get started into the slides and demonstration, just some housekeeping stuff that we have to go through. So Q&A, ask your questions using the Q&A icon, and we'll do our best to get to those at the end of the session. There'll be a very short poll pop up at the end of the session. We appreciate your input on that. And lastly, we always get asked, yes, there will be a recording shared in the next day or two. So just from an agenda perspective, Seqera at a glance, I'm going to just quickly tell you who we are and what we're doing these days. And then Isha is going to jump in and give you an overview of the Seqera Cloud product, as well as the Data Explorer capability. And she's going to tell you about the next big thing that's coming from Seqera platform as well. And then we'll get into your questions and answers. So I always forget to introduce myself in these events. I'm Rob Lalone. I'm Chief Commercial Officer here at Seqera Labs. And I've been with the company for since kind of the early days, fifth employee. Real excited to be here on this webinar with you. And we've got Isha here from our scientific development team, who is the far more qualified person to be talking to you about all this good stuff. So we'll turn it over to Isha momentarily. So first off, who are we at Seqera? So we're really the creators and stewards of the Nextflow project. You're probably somewhat familiar with Nextflow, given the fact that you're here, and many of you were talking about NF Core pipelines. So that means you know Nextflow. You probably heard of Evan and Paulo, the creators of Nextflow. Started it 10 years ago back at CRG Lab. And since then we have hundreds of thousands of scientists using the product. We've got over 1,000 open source companies involved in the project in various forms, whether that's hanging out on Slack or contributing in Git or Common Room or what have you. We've got about 150 commercial customers as well using the Seqera platform. We're very invested and committed to open science. We spend a lot of our time and investment in open source projects like Nextflow, like MultiQC. Many people don't know MultiQC is actually a Seqera project now, as well as spending a lot of time investing in the NF Core project as well. So that's just a real quick glance at us. Our company, well, we spend a lot of time in open science, and open source has a commercial platform, Seqera platform. You probably know somewhat about that because many of you registered to use Tower Cloud already, and now it's called Seqera platform. There are a number of components to that platform. As you know, Nextflow is a big piece of that platform, as is MultiQC, Fusion, our high performance file system, and Wave for container provisioning. We're going to get to that in a little bit, and Nisha's going to show you that, so I won't steal her thunder too much. But let's take it right back to the beginning and talk about Nextflow project. So Nextflow is a language and it's a platform for building and executing reproducible workflows. People love Nextflow. I think they tell us, and we believe them, that they use it for portability and scalability. Those are big reasons why they use it. But I think something that really differentiates Nextflow as well is the fact that it was built using this modern DevOps architecture. So storing your pipelines in Git repositories and versioning and everything, and being able to pull your containers from container registries like Key or Azure Container Registry or the various hubs that are out there. And really the ability to run your pipelines in a very portable manner across all kinds of diverse environments, whether you're running on an HPC environment on premises, using something like Grid Engine or Slurm, or whether you're running in the cloud, whether that's Azure or Google or Amazon, or running on Kubernetes. The pipelines are portable across all those different environments, and the platform allows you to very easily connect to those environments. So bioinformaticians don't have to be working in, say, the Amazon console. They can be just worrying about running their pipelines and not getting caught up and becoming infrastructure experts. By the same token, the next layer down, the storage environments become very abstracted as well and allow you to store your data where you want to store it, and hopefully reduce movement, reduce egress cost, and just allow you to work the way you like to work with your bioinformatics pipelines without dealing with the complexity of managing infrastructure. The Nextflow project is growing very rapidly. You can see here, we're really excited about it. We have about 160,000 monthly downloads of the documentation every month. By the same token, we also have the NF Core project. It's kind of an adjacent community to Nextflow, where community people are building, managing pipelines and related tooling out in the open It's a phenomenal project. There's about 90 pipelines right now. While Seqera participates and contributes to this, there's a lot of other people in the community that are, kind of the real people behind the project and are driving things forward. And there's all kinds of people from various institutions around the globe, as well as commercial entities involved in this. Some of our own staff are involved, as you see on the left-hand side. Phil, the creator of MultiQC, is one of our senior project managers and still very involved in NF Core and founded it in the early days. We've got Geraldine, who joined us from the Broad fairly recently. She's our lead advocate here at Seqera and she's on the NF Core team, as well as an advocate for the Nextflow project. And many of you would know Harshal Patel, who heads up our SciDev here at Seqera Labs as well. So they're all very involved, but they're not the only ones. It's a big community. I think there's 6,000 people in the NF Core Slack right now. Isha, I'm going to turn over to you to talk about the different capabilities of the NF Core resources.
Awesome. Yeah, so the great thing about NF Core is not only do you have a community, but you also have a lot of available resources that make developing Nextflow pipelines a lot easier and simpler as well. Some of those include available open source pipelines that you can kind of run out of the box as is. We have over 90 of these. We also have what are known as modules and sub-workflows. Modules are just your most atomic unit of a pipeline that allow you to run a single tool in one single process definition. So we have over 1,000 of these available that you can just install into your pipeline as is. And then should you want to stitch together maybe one or more of these modules, we also have sub-workflows that offer a higher level of functionality within your pipelines that you can use kind of out of the box. In addition to that, we also have linting tools that kind of make sure that as you're developing your pipeline, you're using best conventions and best practices. And things like schema that allow for validation to make sure that your pipeline parameters are valid, provide a user interface for creating a schema. And then lastly, just tooling in general that you can use on the CLI to develop your pipelines, use a template for it, and then also better deploy your pipelines too.
Thanks, Isha. Certainly, NF Core has been growing very rapidly. You can see the growth of both released pipelines and in development pipelines here. I think we're sitting up around 90 pipelines now, as Isha mentioned. I think the growth of modules is even faster, right, Isha? I think we're well over 1,000, and that number has been ticking up, very quickly as people start using DSL2 and making things much more modular. We're seeing all kinds of modules for all kinds of tooling being developed, and that's accelerating the development of overall pipelines and also allowing customers to leverage those modules into their custom pipeline. So it's not just an NF Core thing, but this tooling can all be used in your custom pipelines as well. So Seqera platforms made up of a number of layers. We're getting to the best part of where I can turn you over and get rid of me and have Isha give you a demo. But at the lowest level, we've talked about this infrastructure management that Nextflow brings to the table, and Tower makes it even more abstracted for the user, so they don't need to be worrying about cloud infrastructure and schedulers and containers. But all of those things come into play in the underlying layers of Seqera platform, so that you can leverage your infrastructure to get your work done. There's foundational technologies from Seqera, most of them open source, like Nextflow, MultiQC, and Wave, as well as our Fusion high-performance storage solution. We encourage you to check those out. We're not going to spend a lot of time on those today, but I think they're all exciting components in their own right. Going up a couple layers, you can see that the platform can be leveraged by the UI, which you're going to see today. But if people want to do automation, they can do it through the API or the CLI, or they can have event-driven activities to drive the platform as well. Isha's going to talk about exploring and managing data with Data Explorer today, and she's going to show you how to launch pipelines, how to set up compute environments, and then we're going to give you a teaser about the notebook capability that's coming very soon as well in the product. The benefits of using Seqera platform, certainly our customers tell us reducing cloud expenses is a big one. We've got a case study on our website from Arcus that talks about having saved 40 to 50% of their cost savings, or having 40 to 50% of their cloud spending by using the Seqera platform. So that's exciting. Reproducibility is a big deal with both Nextflow and Seqera platform. You want to be able to ensure that you can reproduce what you ran 6 months ago, that you can go in and see what containers were used, what tasks were run, what data was used, what the data provenance was, all that kind of stuff. So reproducibility is important and really enhanced through the use of Seqera platform. I mentioned automation already through the use of APIs and CLIs. You can pick up files as they come off the sequencer or arrive in a bucket and automatically have pipelines run against them, for example. So lots of automation capabilities. The flexibility of provisioning your infrastructure. so that you can just very easily spin up a batch cluster or very easily leverage Kubernetes to run your pipelines without ever becoming, a certified Kubernetes engineer, for example. Being able to collaborate with the platform. Users can work in the same workspaces. They can see each other's runs. They can go back 6 months and look up what someone else did if they've got the right privileges to collaborate to ensure reproducibility. And overall, we're seeing a big productivity boost. Sage Bionetwork said they had a 50% productivity boost when they shifted to using Seqera platform. So just a few data points there and some benefits on the Seqera platform. Probably felt a little bit look like marketing, so I'll stop it there and just tell you about our customers real quickly. So we've got thousands of organizations using Nextflow, and like I said, about 150 using the commercial platform, 11 of the top 20 pharmaceutical companies, a lot of very high volume processors like Invitae, 23andMe, Ancestry. The CDC is a big user of the Seqera platform, and over 100 biotechs and academic organizations, research organizations using the product. So I'll stop there, and I'm going to turn it over to Isha to give you a demo of the product.
Awesome. Thanks, Rob. I'm going to go ahead and share my screen if you give me 1 second. Alrighty. So for the next couple of minutes, I'll be giving you a demonstration and walkthrough of Seqera Platform Cloud. So Seqera Platform allows you to manage your Nextflow pipelines, make monitoring, logging, and sharing workflows and executions much easier and simpler on your own compute and storage infrastructure. So I'm going to go ahead and log in. A couple different ways to log in. You can use a GitHub account, Google account, also an email. If you choose to use your email, a link will be sent to your inbox. Go ahead and log in with my Google account. You'll notice that immediately when we log into Seqera Platform that we're placed in what is known as a workspace. All of the Nextflow pipelines that you'll run, as well as the compute on which they will be executed on, as well as deciding which users have access to running these Nextflow pipelines, these resources will be contained in what we call a workspace. This is an example of a workspace. It's called Showcase, and it belongs to an organization called Seqera Labs. You can also create your own account on Seqera Cloud, log in, and when you do, you'll be immediately placed in what we call the Community Showcase. This is where we have a set of NF Core pipelines pre-configured on the Launchpad where you can come on and basically start launching any of these. And we also provide compute on AWS to be able to get a feel for what it's like to launch pipelines and monitor pipelines on the platform. When you log in, you're also able to create your own organizations and workspaces and also decide what kind of pipelines you want to add to the Launchpad and where you want your compute to be. I'm going to move into the Showcase workspace that I was just in. And when you first go into a workspace, you'll notice that you're placed in the Launchpad. The Launchpad is where we can configure our Nextflow pipelines and also tie them to some form of compute. In this workspace, you'll notice we have a set of NF Core pipelines, some of which are tied to an AWS batch compute environment, but also others that are meant to be run on Google Cloud and Azure too. Now, let's just say I have a Nextflow pipeline that I've written, but I want to share it with my colleagues, and I want to allow them to also run the pipeline, but I don't want them to have to do it through the CLI. So what I can do is I can add a pipeline to the Launchpad here to configure a workflow that anyone else can execute if they have access to this workspace. So in this case, I'll specify a name for my pipeline. In this case, I'll be using the NF Core RNA-seq pipeline as just an example. We could add a description here to indicate what the pipeline actually does. Additionally, maybe your pipeline is pre-configured to use a specific tool, or maybe it's meant to be used with a specific data set. You could use pipeline labels here to basically identify your pipeline as such. And when you add a pipeline to the Launchpad, this is also where you will indicate where that pipeline should be executed when it launches. Now, in a second, I'll show you what it looks like to actually configure your own compute environment. But for the example that we're showing here right now, I'll just select from one of the pre-configured compute environments we have available in this drop-down menu. So we have three that are meant to use AWS Batch, but we also have the option of easily configuring these pipelines to run on Azure, Google Cloud, and Slurm. Additionally, I also want to specify where my pipeline is actually located and what repository my source code lives within. This could be a GitHub URL, Bitbucket URL, GitLab URL, Gitea URL, really whatever your wherever your pipelines are located, both public and private. And when I specify a GitHub URL here or any URL, what happens in the background is Seqera Platform is going to go fetch all of the available branches and tags on that repository, such that when I click on the revision number here, I'm able to specify the exact version of the pipeline that I want to run. Subsequently, maybe your pipeline is pre-configured and has some profiles that allow you to run the pipeline with a select set of parameters, or maybe select set of input data or data sets in general. We can indicate those profiles here. For this particular pipeline, I want to run a very, very small test. This configuration profile will use a minimal test data set, which one is great to have in your pipeline to ensure pipeline functionality, but also in general, a great test to run when you're configuring infrastructure as well. And we can also kind of pre-populate our pipeline to use a set of pipeline parameters. So for example, if I wanted all users to launch this pipeline with a specific reference genome version, or maybe I want them to always save their output results to a specific directory and or bucket, I can pre-populate my pipeline parameters here. Subsequently, every time I launch this pipeline and or my colleagues launch this pipeline, they will inherit these parameters accordingly. There are some advanced options as well. We can provide any additional Nextflow configuration settings here, as well as modify the actual environment in which Nextflow runs within through a pre-run script or post-run script to trigger some sort of script and or activity after the pipeline completes. So just to give you an overview of what we did, we are adding a new pipeline with this name. We're going to be using the NF-core RNA-seq as an example with this particular version, and we're going to run a very small minimal test set. And let's go ahead and add this pipeline to our Launchpad. And now you can see that I've configured my Nextflow pipeline here on the Launchpad for other folks to run as well. In general, your resources in a workspace are separated into two different categories, where your first category will be your Launchpad, which includes the actual workflows that you'll execute, as well as data sets, which can be provided as input to your pipelines. We also have a second category, which is known as your compute environments and credentials, where you'll configure where your workflows are actually executed on your own compute and using your own storage. Now, before I launch this pipeline, typically Nextflow pipelines require a sample sheet. They take sample sheet as an input where it will encode information about my input data, where that input data might live, and any kind of information about my samples. And if you're working on the cloud, you can upload this sample sheet into a bucket or retrieve the path for a sample sheet in a bucket if it already exists. But in a lot of cases, users, bioinformaticians, scientists might not even have access to the Cloud Console or CLI. So in that case, what we can do is make use of a feature called datasets on the platform that allow us to basically upload a structured TSV or CSV file, notably a sample sheet, to make it available for all users within this workspace to be able to provide as input to their pipeline. So in this case, I'm going to use a small sample sheet. I'll provide a name here. You can add a description as well. I already have it available locally and I've created it. So what I can simply do is just drag and drop this file into the UI. And you'll notice that I have my sample sheet rendered here, where the first column is just my sample names. And also I have second and third column encoding the information as to where my actual FASTQ files live. Now, because this is just a test data set, the files are small enough that they're stored in a GitHub repository, but you can imagine that if you're working on an HPC, this could be a path to somewhere on your local file system, or it could also be a path to an S3 bucket, Google Cloud Storage bucket, or Azure storage as well. So what I'm going to do is go ahead and add this data set here. And now I can provide this as input to my pipelines. But consider an example where maybe you have a sample sheet that exists in some form of bucket on the cloud, and you want to use that as input. We can leverage a newer feature of Seqera Platform called the Data Explorer, which basically allows you to remotely browse, view, and visualize data that is stored across all the 3 major cloud providers in multiple regions, multiple accounts. And you can see here in this workspace, we can see how this is illustrated. We have a couple different AWS buckets in different regions, also buckets in Azure and Google as well. And if we go into one of these, you can view the full contents of your bucket, as well as be able to preview files within that bucket. So for example, in this 1,000 genomes bucket, I can see information about any files that are in here, as well as the size of the files, and be able to navigate through the directories. Subsequently, what I can also do is download directly from the Data Explorer as well. So as an example, let's just say I have some sort of reference file. This could be a test reference file that I want to use as input to my pipeline, but I also want to make it available on the cloud. What I can do is upload a file directly through the Data Explorer. So I'm just going to go into this bucket here. We'll use as an example. There's no data in here currently, but what I want to do is I'm going to use a reference FASTA file for my pipeline test, and I also want to upload it into this bucket. So what I can do is click Upload File, select for my FASTA file that I have locally, and you'll see that my file has been successfully uploaded into this AWS bucket without me actually having to go into the AWS console or use the CLI to do this. Now, subsequently, if I want to use this as input to any of my pipelines, I can simply just copy the path and provide that as a parameter. I'm going to go back to the Launchpad, and now we're going to go ahead with launching our pipeline. When you click Launch, you'll be brought to an additional form that allows you to specify pipeline parameters at runtime. And the form that you're seeing here is actually rendered from a file that lives in your source code repository itself. It's called a Nexus schema JSON file, and it basically describes all of the available parameters for your pipeline, descriptions of those parameters, and creation of that file is also enabled through the NF Core tooling utilities that I mentioned earlier, so you don't have to do it yourself. You'll notice that this form starts off with some sort of auto-generated workflow run name. We can also modify this if we want. We'll see our labels that we added in the previous step also rendered here. We can add labels too. And more importantly, we need to indicate what our inputs and outputs are going to look like. So as I mentioned, this could be a path to some sort of sample sheet in an S3 bucket. But instead, what we can do is use the data set that I just added in the previous step and use that as the sample sheet input for my pipeline. Subsequently, you could also use the Data Explorer tab here to navigate to a bucket that already contains your sample sheet and use that as input. We also need to specify where our output files will live. In this case, I already know where I want them to be, so I'm just going to quickly specify the path here. And we have some additional parameters that we can specify to the pipeline. It's a very, very mature pipeline, so there's a lot of different functionality and customization that you can provide before you run it. So I won't go through everything, but what I did want to point out is that because I now have that reference FASTA file that I uploaded via Data Explorer in a bucket, I can simply copy and paste that path here and use that as input for this particular FASTA genome file parameter. Alrighty, so what did we just do? We have our pipeline parameters. We have specified where our input is coming from through a data set. We have an output directory, and I've also been able to upload a reference file and use that as input for this pipeline. So let's go ahead and launch. And when you launch, you'll be brought to what is known as the runs page. This is where we can monitor and inspect the details of workflows that I would have executed, but also workflows executed by my colleagues. You can see an example of that here. My colleague, Adam Talbot, on my team has also run a pipeline, and I can take a look at the results of that. And you'll also see the status of your workflows as they transition from submitted to running to hopefully succeeded. This is the particular run that I just kicked off, so we won't see any useful information right now, but what I can do is instead show you a previous run of the same pipeline to give you a sense of what it looks like to take a look at the run details. So when you click on the run itself, you'll be given this first tab, which is the command line invocation. So if you're running Nextflow via the command line, this is typically what you'd be doing. You also get the full set of parameters that were used for that pipeline, which is great for reproducibility because we can also copy and paste this, but download it from the UI. This allows you to recreate the exact results of a pipeline, as well as the full kind of resolved Nextflow configuration. And if you had used a data set, you'd be able to link back to it here. And when we click on the execution log, we'll get the full kind of Nextflow log that we typically see if we were running Nextflow via your command line and what you'd see streamed to your console. And I'll give you information about what pipeline you're running, parameters, and processes as they begin to be submitted. This can also be downloaded from the UI. And one of the great features of Seqera Platform is this reports feature. So what this allows you to do is, should you have any pipeline outputs that you are generating, we're able to actually view these within the platform itself without having to actually navigate to cloud storage. A good example of this is the multi-QC report that the NF-core RNA-seq pipeline generates. It's a great utility that is helpful for getting a sense of how your data ran, what the QC results look like, and it aggregates statistics across various different bioinformatics tools. And you can imagine a scenario where maybe you have some colleagues that are interested in seeing how a demultiplexing run went, or they just want to get a sense of whether your reads were aligned correctly. Instead of having to set up access for them through storage and infrastructure, we can actually view these results directly within the platform itself. And you'll notice that the path is still pointing to a location in cloud storage, but the platform makes it much more transparent and easily accessible to view results that exist in the cloud within the platform itself. We can additionally download them for the UI too. We scroll down, we see some general information about who ran the pipeline, the exact commit hash that was used to execute the pipeline, what version of Nextflow we had used as well. And this pipeline has completed, but you'll also see tasks move from status of pending to submitted to running. And when you click on any one of these status boxes, you'll be redirected to this tasks table, which gives you more information on a per task level. And should you click on any one of these, you'll be brought to a task details window where you can see the full command that was run for that particular task, where your task work directory lives, information about execution time, resources requested, how many CPUs and memory did you request for this task? And if you're working on the cloud, you can also see information like what VMs were provisioned and or machine types, and a rough estimate for cost as well. Now, typically what happens is Nextflow will create a task directory for each task of your pipeline, and this will contain things like your .command files, standard error, standard out log files as well. And the contents of this directory in the cloud are typically somewhat hard to find at times because Nextflow will create a unique hash for each of these tasks. And so the contents of this directory are still helpful for troubleshooting if things go wrong. So instead of having to navigate into cloud storage paths to find information about why the task failed, instead, what we can do is actually use the task details window to take a look at the execution log, which you can also download. Or through the Data Explorer, view the exact contents of your task work directory within the platform itself and not even have to navigate to the bucket. Here you can see we have our .command files, and you can see any intermediate files that might have been required for that task, which we can also download from the UI. Lastly, some further information on the runs details page. We can see information on a kind of per workflow level about CPU metrics, memory, job duration, and I/O. But let's just say when our pipeline finishes, you might want to see the and take a look at the actual outputs of your pipeline. While we can do that through the reports, maybe you want to see additional outputs that are not rendered here. We can go back to the Data Explorer, navigate to the bucket in which my results would have been saved in. And now I'm able to kind of see the full results that are generated by my pipeline, again, within the platform itself. The nice thing here is that should I want to use any of these outputs as inputs for later pipelines downstream, I can simply just copy and paste the paths that I'm able to retrieve from the Data Explorer. So Data Explorer is great for viewing the contents of your own buckets that are enabled through credentials you would add on the workspace, but a lot of useful reference files or data in general used in bioinformatics are also contained in public buckets and in the public domain. Now, if you want to use those files and or data within your own pipelines, you might want to have to copy over that data into a bucket that you own and or use the CLI or console to do this. Now, the Data Explorer kind of circumvents these issues because we can add a public bucket to be able to browse and view the contents of directly within the Data Explorer itself. And so let's just say I want to use some genome in a bottle data for some benchmarking efforts and getting a sense of how precise my variant calling might have been in my pipeline. What I can instead do is just add a cloud bucket onto Data Explorer itself. You'll notice that I have the choice between the 3 major cloud providers. My bucket is specifically in AWS, so I'll choose that. I'll specify the path to the bucket. And if it's private, then you'll have to provide some form of credentials in order to authenticate. Here, I'll just specify a description. So I'm going to use genome in a bottle, consortium data, and add my bucket. Now you'll see that I have my publicly available data viewable and available to me within Data Explorer itself in this particular region. So let's just take a look at the contents of it. You can see that I can now view the contents of this public data without even actually having to navigate to AWS or use the CLI. I can view and preview files as well, maybe take a look at the manifest files that give me information as to what the public bucket actually contains, and be able to download these files too. And in the event that I want to use any of these as input, I can simply copy and paste the paths provided to me here. Now you'll notice that the previous pipeline that I just ran was in EU West 1 or Ireland, but maybe I want to perform some analyses on this particular data set that is not in that same region, but instead in US East 1 or Virginia. Now, instead of me having to move this data into a bucket within the Ireland region, what I can instead do is use some of the Seqera platform backend features, which I had mentioned earlier, so compute environments and credentials to create compute and bring compute to my data instead. Before we do that, you typically need to add credentials, which will allow you to authenticate and access your own infrastructure. So in the case of AWS, we would specify the form of credentials in an access key and a secret key. But just to also highlight how to use credentials, if you are using a private repository where your pipelines are contained, you would also add credentials for things like GitHub or wherever your pipelines are currently located. And once we have credentials, then we can allow the platform to access our infrastructure and authenticate accordingly, and subsequently create a new compute environment. When you create a new compute environment, we'll also define where our workflows will be executed. And so in the case where I want to create a new one that allows me to run my compute in the same region as my genome in a bottle data, which was US East 1 or Virginia. So here we can say, let's compute. I'll add a name here. We can also specify which platform we want to use. So we'll stick with AWS, but you can see there's a couple different other examples as well. So all 3 major cloud providers, schedulers, Kubernetes, and Kubernetes managed services as well. All right, so here I have some credentials that will allow me to access my infrastructure. I'll also specify the region. In this case, I want it to be US East 1. And my pipeline work directory will also be a bucket that's also in this region. And when you create a compute environment on AWS Batch, we have 2 different methods of configuring how our resources will be provisioned. As a bioinformatician, I don't like dealing and managing infrastructure. Instead, I kind of want to let Seqera Platform do that for me. If I choose this configuration mode called Batch Forge, what the platform will do is go into your AWS Batch compute environment and automate the provisioning of resources for you. Now, in the case that you might already have these things available and set up, that's also okay. We can use the manual mode and specify the names of our queues within these two text fields below. Additionally, and Rob touched on this earlier as well, we have some newer kind of solutions and technologies that allow us to circumvent common problems we have with running bioinformatics pipelines in the cloud. The first one being Wave, which allows us to access private container repositories with images that you might use for your pipelines, but also provision containers on the fly. And we also have Fusion version 2, which allows us to more efficiently access and make data available to common bioinformatics tools and tasks much more easily and more efficiently as well. Typically, a lot of tools that will run in bioinformatics will use large data sets, and by storing these data on blob storage, we can introduce bottlenecks in retrieving that data for our tools and subsequently copying data back out to blob storage. So Fusion version 2 basically allows us to circumvent these issues by making that data in blob storage available within your task itself as a distributed file system. And overall, we see a lot of performance gains in using this. We have a blog post that briefly describes the benefits of using Fusion version 2. And should we want to benefit from additional performance gains in using Fusion version 2, we can also use specialized disks and/or fast instance storage to speed up I/O and get data access quicker. When I create my compute environment, I can also decide what kind of VMs do I want to use. Do I want to use spot VMs that will allow me to save some money? Or do I want more reliable kind of VMs that I know won't be reclaimed I can use on demand? I can also set a ceiling to the number of CPUs that I will use in this compute environment. And some additional options for things like using Fargate for your head job. And another thing I want to point out is maybe you want to perform some cost tracking to understand what is your spend on these pipelines that you're running. We can make use of resource labels to attach basically name value pairs to anything that we provision in this compute environment, and subsequently be able to use that for cost analyses and just get a sense of what your spend is when you run pipelines through the platform. Lastly, maybe you want to be more conservative about the instance types you're using, or maybe you want to use newer instance types that provision larger resources for your tasks. You can provide the exact kind of families and sizes of your instances here. And there's some additional options that you can provide when creating a compute environment, but I won't go through everything. There's networking options and options for how you actually provision the head job as well. All right, so let's go ahead and add our our compute environment. And so you can see that now I have my newly created compute environment, which I can bring to my data to use my newly created genome in a bottle bucket. Subsequently, if you want users to be able to also use this compute environment, you can modify the default compute environment that we were using for our pipeline that we just added to use the newly created one. It'll probably take a second to create, but you'd be able to see it in this drop-down menu here. Subsequently, should you want to be able to specify it at runtime, you can also do that through the launch settings. So you can see that Data Explorer makes it really easy to be able to remotely browse buckets that we'd use for analyses, but also be able to manage data across different cloud providers, across different regions and different accounts without ever having to interact with a cloud console itself or use different CLI utilities for AWS, Azure, or Google. And lastly, a couple of different things I want to mention. In the workspace itself, I mentioned adding pipelines and compute, but you can also define who has access to these resources you would configure. So should you want users with higher level of permissions, you can define them to be power users and/or contained between these different categories, admin, maintain. Or do you want your users to just be able to come on to the workspace and be able to launch pipelines, take a look at how your runs went? We can also configure them to be Launchpad users, so either launch or view. Lastly, to end off, a couple different ways to interact with the platform that don't have to be through the UI. We have a full API spec that allows you to perform most of the actions I showed you right now, but through the API, as well as a CLI utility that, again, allows you to launch pipelines, create compute environments, but also export configurations for both of those things as infrastructure as code, which is also helpful. And we also have a blog post that describes how you can easily get started with using Seqera Platform Cloud and describes kind of the steps in getting you set up to be able to run your own pipeline in less than 30 minutes. Alrighty, I'm going to stop there and hand it over to my colleague, Rob.
Awesome. Thanks, Isha. I'm just going to share my screen again. And I think you are first up. In any case, we're going to talk about some of the new things. I'm just waiting for my screen to show. Hopefully you can see that now. So what's to come? I think we've got some really cool stuff coming from the standpoint of notebooks and studios. And Isha, why don't you tell them about that next?
Yeah, definitely. So, I showed you a little bit about using Data Explorer to manage your data across clouds, but this new upcoming feature called Data Studios will also allow you to launch interactive notebook sessions, environments to be able to better interrogate results that you might generate from your analyses on the platform, be able to do tertiary analyses, downstream analyses, even debug, troubleshoot pipelines, and in general allows you to interact with your data much more. And additionally, you can develop tools and workflows in their native environments using the data that you would have been generating through the platform and through the runs that you would have executed on the platform. Additionally, to kind of customize the environment in which you would do this, you can create your own containers depending on which tools you want to use, define what dependencies you want to use in these environments, and also it makes it much more collaborative to be able to share results of these analyses with your colleagues and be able to reproduce these results as well. So stay tuned for this.
Cool. And we've actually got a webinar coming up. The next webinar will be to show you Data Studios. I think that's next quarter, and we're pretty excited about that because it'll be available in preview at that time. So now we'd like to just do a quick poll. It should be popping up on your screens. If you want to get a little more information from us, select the one-on-one meeting. I think there's an option there for it, like schedule a personalized demo. That's it. So yeah, you can indicate that you're interested, and we could talk to you more about in depth in the various areas that we just touched on today, or drill into studios or drill into compute environments or whatever it is that might interest you. So we're happy to schedule some one-on-one time. Hopefully you're through that. And now I'd like to jump into the questions and answers. So I did see that we had some Q&A here. Just check in the chat first to move them all over. That's good. So the first question is, does Seqera platform only support pipelines written in DSL2? Isha, I'm going to get you to answer that one.
You can configure pipelines to be run on the platform through DSL1, though I think there's definitely a recommendation that your pipelines use the kind of most up-to-date DSL, which is 2, but it is possible.
Cool. And the next question is, do you get access as a Seqera user to those computes, or that is just there for demonstration?
If you're referring to the compute in the community showcase that I just showed you, that is just there pre-configured by Seqera for you to use at a limited kind of amount at 100 CPU hours. However, if you want to use your own compute, you can subsequently create your own organization, create a workspace, and configure a compute environment as I just showed you to be able to use your own infrastructure.
Exactly. We're happy to help you set those compute environments. I think that tends to be one of the stumbling blocks when people wander into Tower Cloud on their own. They can't quite figure out how to set up compute environments. So ping us and we'll be happy to help you get that set up if that's of interest. Working at a public institute with its own HPC, could I add this HPC as a compute environment instance? Go ahead.
Great question. Yeah, so kind of going back to the earlier point, you can create your own workspace, and what you can do to configure utilization of your own HPC, there's a couple different methods of configuring compute environment. You can use SSH access through adding a compute environment to be able to SSH into your own cluster and run pipelines. We also have what is known as a Tower agent, which would be a background service that would be installed on your own cluster, run in the background and be able to submit jobs to your scheduler accordingly. So a couple of different options. We're here to help you out with configuring that if that's of interest to you.
Great. We just had a Data Explorer question come in. Is access based on credentials? What if we have lab users who don't have AWS access but are launching pipelines?
Great question. To answer the earlier part, yes. The access that you'll see and the buckets you're able to browse in the Data Explorer are based on the credentials you would have added into that particular workspace. So you can decide based on whatever access key, secret key you've configured, which buckets are empowered to be put access with those credentials. And you can also hide buckets on the Data Explorer as well. So we definitely recommend that depending on what level of access and visibility you want your users in that workspace to have, to configure your credentials accordingly.
Thanks, Isha. Is there a concept of biological samples in Seqera? Example, sample one reads with Illumina, nanopore, etc., and certain metadata, source, collection, date, location, etc. If so, can sample sheets be generated in the UI based on this info and metadata?
Great question. Currently, sample sheets have to be provided through either data sets or some sort of path where the sample sheet might be currently stored. I think eventually the idea is that data studios might also enable you to create sample sheets through the interactive environments, depending on what kind of data you actually want them to encode.
Excellent. I see one more question here. When is the next Nextflow training? So I think if you go navigate to the NF Core website under events, you can see the next training that's coming up. That's publicly available. It's the Foundations course, and it is in March. So get yourself registered there, and maybe one of my colleagues can post that link in the chat for you as well. Okay, and I'm about to sneeze. Bad timing. So why don't you talk about what happens next, Isha?
Sure. So if you found some of the features that you saw today interesting, we'd be happy to provide a further demonstration. You can reach out to us at the link provided here for a one-on-one demo. We can also delve into any specific features that you might be interested in as well. And additionally, we also welcome that you join our Nextflow Summit, which will be hosted in Boston in May of 2024, where you'll see some in-depth presentations and talks on some of the features that you saw on the platform, also what's to come, notably data studios, as well as some presenters and featured guests that will give us information and talks on how they've been using the platform and Nextflow in their own work as well. So feel free to navigate to that link to be able to subscribe and join.
Well done, Isha. I know that was my slide to cover, but as I said, I had to sneeze. Good,
Okay.
good save. That brings us to the end of the presentation and the demonstration. We're really happy to have you here. If you have follow-up questions, please reach out via our website, or we'll be sending you some follow-on materials if you request that, and you can request additional information, meetings, and such with us. We're really excited that you joined us today, and we're looking forward to seeing you get going with the Seqera platform and hopefully making use of some of the tooling that Isha showed you today. So thank you very much again, and we'll see you again soon.
Thanks, everyone.